Hi, so this is a Tesla pump configured as a blower. Now, the rest of the video is going to be about how to actually make this, and then at the end of the video, what I'll do is give you a demonstration of why I actually want it. First thing we need to do is cut out a whole load of squares, and I don't cut out a whole load of squares. You can either mark the plastic, or you can do what I've done, and that is draw your squares on a piece of paper, because obviously it's see-through. Draw them on a bit of paper, it's much easier to actually see where your lines are, but you have to make sure everything's lined up. And when you've lined it up, you need some kind of straight edge that you can put on there. You can do it with a smaller ruler, but you get little jagged points on it. It's better with one clear, continuous straight edge. Now this stuff cuts really nicely with nothing more than a knife like this, but you have to make sure it's sharp, and you don't dig in hard. You just line it up and draw it quite gently down. And you do that a number of times. If you try to dig in hard, you'll skip around. Just draw it gently and it will actually just cut through. And we just mark out those lines, flip it over, mark them out again, and then it will just snap off. So I'm going to draw down those lines. So I've marked out 24 squares at 125, scored them out, and you can see them quite clearly. So taking the paper away, turn it over and repeat on the other side. Now your blade's going to get blunt, so make sure you change it frequently and often. Because the secret here is not to put a lot of force on it, use sharp tools and do it gently. And then when you're ready, just line up some kind of rule with your other side and repeat the procedure. Just score down it. It takes surprisingly little, in fact only about 4 cuts with the knife on either side goes through. You'll feel it kind of crackling, but once you've done that, you're ready just to snap them off, and they snap off quite cleanly. And you snap them off into your squares. There you go. And you're making 24 of those. Right, so the next thing that we need to do is mark out the centre. Purists will hate this, but all I do is take the piece of paper I've drawn, draw crisscross lines so you've got the centre of the square, line the square up, take something like a nail, put it into the centre, and then give it a couple of taps with a hammer. And you'll get a centre mark. Again, you don't want to go crazy with it, because if you punch the nail through, you'll actually crack the sheet. So just mark it up with the centre and do that to all 12. Okay, so we're going to drill them out. Now I'm using this thing to drill them out with, and it's basically a large one of these. It's just a hole saw with an arbor, and that arbor's 6mm. That'll become important later. They're actually relatively expensive, these things, but you can use this, which is a much cheaper version. The problem with this one is it wobbles around quite a lot. Even when you try to keep it straight, it won't do it. And you get quite a rough hole. But with this one, you get a much neater job. But, you know, it's 6 2/3. It's just going to mean you're going to have a bit more cleaning up to do afterward. Now, I've lined this up with that punch hole that I made earlier, and I'm going to drill it out. Now, the thing you need to know when you drill this stuff out, so see, trying to line it up. There we go. This material gets hot, and when it gets hot, it doesn't cut, it melts. So the thing you don't want to do is take it quickly. You need to take it slowly. When you see it start to curl up in a kind of blob, you know it's melting, so just ease everything off. Don't try to drive it through. If you drive it through, you'll melt it and snap it. You'll be really sorry. So the trick is, again, just like with the knife, take it easy. Okay, so once you've drilled out 24 of them, you'll end up with 24 of these. Now, they're more or less, or some of them are more or less guaranteed to jam up in here. So all you do is, it's got a hole in it, just give it a whack with the hole and the plastic disc will pop out. And you'll end up with 24 plastic discs like that and 24 little squares like that. Now you need 12 of those. So you pick out 12 of them, and you'll see they've got this rough curly edge to it where the plastic melted and made little curls. And you need to clean that off. Now it's easy enough to do, just take a trimming knife and scrape around it. Once you've scraped around it, then it's got a clear plastic cover on it to protect it. At this stage, that needs to come off, and it just peels off. So you peel off the plastic covers, and you do that with 12 of the discs. Now they'll still be a little bit rough, so what we need to do is clean those up a little bit more, and the way you do that is get yourself a 6mm bolt. Now I mentioned that the arbor bit was 6mm, and this is where it becomes important. You get a 6mm bolt and a 6mm washer, and it's a repair washer because it spreads the load on the discs. You don't want to crack the discs, so you put your discs onto your bolt, on with your repair washer, and then on with a nut. and tighten that whole lot down. Now what we're going to do is we're going to spin it, and we're going to spin it around that centre. When we spin it around that centre, and if we hold a cutting tool to it, it'll take off all those little last curly bits and make some nice centred discs. There's a couple of ways of doing this. You can put it into a drill. If you've got a drill that you can stand on that way, you can put it into a drill like that and spin it like that. I'm lucky I have this little mini lathe, and we're going to put it on the mini lathe. So here it is fastened up on my bolt, and we just fit it into the mini lathe and tighten the lathe down. Now, the lathe spins in that direction. You can change the direction if you want, but you need to make sure that the bolt is on the right side so that it tightens up as it spins. So if you spin it the other way, it will loosen off. You'll soon know, because if you spin it and loosens it off, swap your bolt around the other way and fasten it all up again. Now, you set it going, but not super quick. Again, none of this work is super quick. Now this will kill people who are health and safety, but I take this blade and hold it like that, and hold it up against there, watching my hands on the chuck and watching my hands on the blade. Now, it will want to snatch at first, so you've got to do this really carefully, but don't jam it in, and don't hold it straight like that. Hold it at a slight angle, and just hold it gently against it, and you'll see it peeling off the plastic, and it'll peel off the plastic and when you've done, it'll give you a set of 12 discs with a 6mm hole nicely centred, and we can undo that then and take those discs out. Okay, so the plan is disc spacer, disc spacer, disc spacer to build up the rotor of the Tesla turbine. In order to do that, of course, we need some spacers, and here they are here. Now these are made exactly the same way, only instead of using this 100mm cutter, we've got this 25mm cutter. So you swap out the cutters, then with a spare scrap piece of plastic, just drill out the holes. Again, take it gentle. And cut out 13 of those. Once you've cut out 13 of those, you need to do exactly the same thing. Take your knife, go around the rough edges until you clean up the rough edges, and then peel off the plastic protective covering that was already on there. Then when you've done that, take your 6mm bolt, put your spacers onto the bolt, fasten the nut down, stick them in the lathe or the drill, and finish them exactly the same way, so that you get 13 lovely little spacers. Okay, so the Tesla works either by sucking fluid in through the centre and chucking out the periphery, which is how it works as a pump, or you can force fluid into the periphery and exhaust it at the centre, which is how it works as a motor. Either way, what you're going to need is a whole load of exhaust ports in the centre of the discs that you've just made. So you've got the centre where the spindle is, and just a little bit off you need some exhaust ports. Now we're going to use these spacers, so the exhaust port's going to need to be beyond the spacer, and I'm going to make the exhaust ports about 1 centimetre big, so I'm going to drill 1 centimetre holes in the centre here, around the centre here, to act as my exhaust ports. And I've got a couple of options on doing that. Now I could either mark up the discs, which to be honest would be a bit of a nightmare, or I could cut out a bit of paper, stick 11 discs on, and then my 12th disc over that bit of paper, and bolt the whole thing down. Now I've got some nice marks that I can drill to. Okay, so I've got this little wooden table, MDF actually, attached to the main steel table of the drill, and in it I've drilled a hole which is big enough to take the head of my bolt so that that doesn't interfere and it's nice and flat on the table. So I've lined everything up, and I've used a small drill bit here, and I can just get to the mark, and as I spin that round, then I'll hit that mark. Now again, resist the temptation to go mad at it. when you start drilling through this, the plastic will melt, and if you just try to drill all the way through all of a sudden, it'll take those and it'll separate them out, and you won't get all the holes in line, and you have a nightmare removing it again. So do everything gently. As you feed it in, you'll see the plastic curl around. You'll see it wanting to melt. When it wants to melt, bring it out, clean the bit, and go through again. Don't rush it, take your time. So when you've done that, you end up with 4 neat little holes evenly arranged around the centre of the disc. And I forgot to mention that I'm starting off small. This is 4mm. You don't want to try and whack a 10mm drill through there, because disaster will loom. You want to start small and increase your drill size. Now you can increase it by 2mm, so 4, 6, 8, 10, and you'll be there. Or you can increase it slightly larger if you're feeling slightly more confident. But again, the trick is slow, clear it often, don't let it melt, and you won't get that dreaded spreading about. I also drew a circle around the centre, incidentally, for the size of the spacer to make sure that I got that right. So now when we've done that, we swap out the drill bit for the next size drill bit up and go through the whole process again. So after you've done that, here are the vent holes all drilled out and in line, and now what we need to do is separate it, clean it up a little bit, and layer up our rotor. Okay, so there's all drilled out and cleaned up and ready to go. Now, the next bit, although it's easy enough to do, you're not going to have a lot of time to do it, so you need to be set up. So you set your desks up in a row, you set your spacers up in a row, and you choose which way you're going to fix it. Now, there's a number of ways of fixing it, and we're basically going to solvent weld it together, because once you solvent weld it, it's as if it was all made of one piece of plastic, basically. It will break on the plastic rather than break on the solvent weld. It's really good. But there are a number of solvents available to you. Now, one thing you can do is you can go down the hobby shop and buy yourself something called Plastweld, which is a pre-prepared solvent. But it's essentially this stuff, actually. This is ethyl acetate. They use it as a type 10 cleaner. It's the same stuff. You can also use methyl-ethyl ketone, or you can use acetone, and you paint the solvent onto the piece of plastic that you're going to weld together, slap on the next piece and clamp it all together. And you can also use this stuff, which is cyanoacrylic glue. Now, as I say, you have to be really quite quick about it. So what we've got here is a bolt which is long enough to take the whole structure, and I know because I've checked, so check before you start. The worst thing would be building it all up, trying to get the nut on and finding it doesn't fit, and having to pull all that thing apart with all the solvent weld in there. It would just be a nightmare. So all you actually do is take the first piece of plastic and put it onto your nut. Then you take one of your spacers and dope it either side with your weld or with your glue. And as I say, you have to be reasonably quick about this stuff. So you dope it with a little bit of your glue, and I'm going to use cyanoacrylic glue because it pretty much has the same effect, actually. And then pop it on there like that. Then you take your next one, again, dope the bottom of your spacer with it a little bit. You don't need much, incidentally, for this stuff. And then you pop that on. Now, the only thing you need to remember when you're doing this is make sure that those vent holes that you spent all that time cutting in line are in line again. So you need to make sure that you line the whole thing up so that you can see through. And then you just build it up like that, spacer, disc, spacer, disc. So there we go, we've got disc, spacer, disc, spacer, disc, spacer, bolt through the centre that's been tightened down to clamp it all down. And you might notice actually I use the drill bit, and sticking the drill bit down one of them means that those holes are nicely lined up. So all I have to do now with that is leave it to dry. It dries quite quickly, but it gets its full strength after 24 hours. You might remember we had a load of these, and we're not going to waste these. What we're going to do is use them. And you do exactly the same thing. Strip off the plastic, clean it up, and you'll have 24 of those things together. And you use the same kind of technique we used to make the rotor, that is some kind of solvent or some kind of glue that it's going to stick it all together. As I've gone through the solvents and glue before, you just slap them all together and put them in a press, and what you get is the body. So one of the handy things about that is, of course, the rotor fits in the body quite neatly. So we've got our body made at the same time pretty much as we make our rotor. And again, just leave those sitting around for about 24 hours. When you come back to them, they'll be nice and firm and dry. Now, I've nearly finished the rotor. I've taken the screw out of the centre, and I'm going to drill it out with an 8mm drill bit. Once you've drilled it out, you cut yourself a bit of 8mm axle. Now this is a bit of aluminium tube at 8mm, and it's going to be stiff to get in there, but you basically just force it in and then put a bit of glue on it to hold it there in place. Once you've done that, that's pretty much the rotor all finished. Now the next thing we're going to have to tackle is this thing, which is the body of it. Now I'm making a air pump with this, so I want the nozzles to be a certain shape. If you're going to make a turbine with it, you need a different shape, because the turbine forces the liquid at the edge here, so you want a shape that comes at an angle like that, so that you get a jet of fluid being forced onto it. So you have an angle cut into it, so you get a thick here, thin here, to jet the fluid on there. But because I want this to take fluid out of here, that is the air out of there, I'm going to cut quite a large section out of that. Done that, you'll get that. Now it does want to spring open, and the rotor is just a little bit bigger than this block that we made, so what you need to do is cut 2 more of those. And now what we're going to do is glue and clamp those there so it holds everything in registration. So now we need to make the end plates. In order to make the end plates, I have to cut 2 squares of acrylic and marked up the centres, and this time they're 4mm thick because I want the body of it to be thicker. But what I'm going to do is drill a large hole in there and use 2 of these things. These are 50mm acrylic pots, of which I've got loads hanging around, and I'm going to sink the bearings into there so that we can run the axle. So the thing will actually glue together like that. The idea being to drill a hole in here, and that will be the gas intake, and as you saw in the body of the turbine, the gas outtake is actually in the body. So the first thing we need to do is drill a hole in that. Now I've set up the drill here with the hole cutter, and the hole cutter is the right size to drill those holes out. So once you cut them out, of course they're a bit messy because they're plastic, so you just clean them up. And when you've cleaned them up, what you'll get is that, and this fits, if you've chosen it quite nicely in there, and that will just glue together. So now what we need to do is actually prepare these to make them suitable. So we're going to use these things, and these are inline skate bearings, so you can get them absolutely everywhere, and they're 22mm on the outside and 8mm on the inside, which is why we aim for an 8mm hole in our axle. Now I want to glue these into here, but I don't really want to glue them, because if I do I'll bugger the whole thing up because I'll glue everything together. So what I need to do is make a small recess in there so that the bearings can go in there quite nicely. Now I'm going to pour some resin in there, so effectively the bearing will sit there, and I'll pour some resin at centimetre high, which is how thick they are, and that will make the recess. But again, I don't want to do that with a bearing because I'll ruin the bearing. But handily enough, being 22mm means that this will do rather nicely, and it's just a bit of copper pipe. So you just cut off 2 sections of 22mm copper pipe, and that will form a mould so that I can put it in there and pour my resin in, and then that will be 22mm, so the skate bearing will then go rather nicely in there. So that's what I'm going to do. So I've clamped those down, and now I'm just going to pour a little bit of resin in there. So about 1 centimetre. Then just leave that resin to turn. So once the resin's set, you pull out the mould and you get this inset, and your bearing will fit quite nicely into it. So you can put a spot of glue around the outside of the bearing, and that will seal the bearing in. Now you need 2 of those, obviously, 1 for each side, but you can't finish them yet because one side has got to have the drive axle because you've got to spin this somehow. So you need to drill through there at 8.5mm, just a little bit bigger than the actual axle, so the axle doesn't rub. The axle will fit very tightly into that, and that'll be part of what makes you seal. But on the other side of it, you need to drill an inlet porthole, something where you can put the gas in. Once you've done that, then the whole thing is ready to glue together. So I've glued one of the end plates onto the body, and what I've done with this is just put a couple of plastic spacers so it holds it all in place. And at the bottom there you can see the bearing. So the whole thing slots together like that and spins around in there. The top plate's been finished off exactly the same. It's got a bearing in there, and we just slide that on and that will close up. Now sometimes you'll get it a bit off centre and you won't be able to spin that freely, so you just need to line it up so that it spins freely and nicely in the centre, And you can check that by giving a little spin, and if you've got a bit off, you can just bring it over a little bit until you get it in the right position. And then when you've got it in the right position, you're ready to glue it down. So there it is, finished. As the spindle that it drives from, the discs are in the centre, and you can see what finishing things I did with it. Basically, in those holes that I drilled there, I stuck some clear tube and glued that in with the plastic glue, put a Y piece on it, and that's going to be my inlet port. The outlet port, I glued on this bit of circular plastic, which is actually just a pot with the hole drilled out leading into the discs, and that's the outlet port. So when I want to port it onto something, I'll drill through there and attach something to there, and then seal around that edge with a bit of tape. The only other thing that I've done that I didn't mention is around the edges of it, I've actually painted it with resin, and that's to seal everything, to make sure that there's no air gaps that I might have missed. So I've painted the outside of that with resin, then I drilled 4 bolt holes through it so that this can actually be unbolted and lift off, and I can take the centre out if I want. And that's meant that in here, what I've had to do is take a piece of sheet rubber and cut the rubber to make a gasket for it and then butt the whole thing together. But there you go, one Tesla turbine as a pump, finished. So there you go, that's how you go about making it. Now, this thing will run at ludicrously fast speeds, even though it's homemade and not particularly well balanced. Now, what I'm going to attach to is a Dremel. This Dremel will turn at 2 speeds, actually 15,000 RPM and 35,000 RPM. So I can get this up to about 70,000 RPM because I put a pulley system on it. This is about twice the size of this, so it's going to be a little bit more than 70,000 RPM at top speed. Now, I've got a little leather belt there that I've actually just made up just to demonstrate this, because I've got some belts on order and they haven't arrived yet. I hate waiting, so I made a leather belt up, and I'll give you a demonstration of it. Now, I have to start it gently, because if I start it too quickly, it'll go like crazy, really. And the whole thing is actually part of a desalination challenge I've got going on. You'll note that the thing here is attached to this flask, and this flask has been heated to 40 degrees centigrade, and it's pretty clear. What I want you to do really is watch what happens to the tube in the flask when I set this thing going, and also here. So it's running at about 30,000 revs, and I don't know how well you can see that, but you'll see that the tube is misting up and it's spitting out little bits of water. So this is pulling enough vacuum to boil that water at 40 degrees centigrade, turning at round about 30,000 RPM. Unfortunately, the belt broke, which is no surprise, there's a bit of bootlace. I've got some proper belts on order, so when the belts arrive, what I'll do is line this up again and see what we can get out of it in terms of speed, but I'm pretty happy with that as proof of concept, and you can see that the mist is dying down again. So what I need to do now is rebuild it in a much more engineered kind of way and get some real speed out of it, because we're showing proof of concept. So I hope that was of interest to you, and thank you very much for watching.